Talks. We are going to have 5-minute conversations where the suitable subject, demonstrated by Mr. Keating himself here at the moment, will deliver a talk on their subject of choice. At 1 minute, I'm going to need a little help in the timing. So I'm going to stand up and I'm going to go like this. And I want you all to say, 1 minute!
I think that wasn't very good. We need to
Try. So,
with gusto.
1 minute! Yay! Alright, so, at 10 seconds, I'm going to stand up and go like this. And I want you all to count down with me. 10, 9, 8, 7, 6, and so on. When we get to 1, I want everybody to shout, System D! So,
time to do questions, or is that?
No, that's it. If you get System D, that's it. It's all dead. So, without further ado, Mr. Keating will be taking our first 5 minutes. Please proceed.
So I wasn't going to talk this year, but I decided that you all want to actually hear me. So I'm going to do a little talk that I did a few years ago, which is part 1 of the terrible things psychologists have done to animals. So psychologists are constantly trying to find out how the brain works, and they do this by testing it on various animals. In the past, it's been done mostly on things like cats and things. So Blackmore and Cooper in the late 1960s and 70s, they wanted to test visual stimulation. So they wanted to look at the effect of visual stimulation on your environment. How do they do this? Well, first of all, we take some kittens. Oh, they're lovely. And we get the kittens and we raise them in a specific environment. Now, that environment could be wholly vertical or wholly horizontal bars. Basically, we jail the kittens. Now, if you put them in horizontal barred environments, they are unable to see horizontal bars for the rest of their life, if raised for the first 6 weeks. So they walk into them. The same is true for vertical environments. The little cats walked into the bars because they'd never seen them. Raise them in only horizontal bars, they can no longer see vertical. Raise them in vertical, they can no longer see horizontal. The responders in the brain don't react. In order to find that out, they sort of cut the kittens apart and looked inside their brains. And they found there was a difference in the neurophysical makeup inside the brain. The neurons responded differently to the different orientation in the visual cortex itself. It actually formed during that period. So there's a sort of condition that's environmental based on the framework that's already existent, nature-nurture. Responses can be affected. This is also true of cats raised in stroboscopic light. You flash the stroboscopic light at the cat in the first 6 weeks of its life and nothing else. That cat then is unable to see movement, which means that you can throw things at its face. That went a little fast. And hit the cat in the ball in the face with a ball. Just by throwing it. Because it just goes, oh look, it's a ball! It's still a ball! It's like, what the hell? Where did the ball come from? It gets better. Instrumental conditioning. Now we all have an example of instrumental conditioning. It's very famous. It's called Pavlovian conditioning. You ring the bell, dog comes, dog eats the food. That's an instrumental conditioning. So Pavlov trained his dogs to sound the bell, but he noted himself the reaction was kind of weird. To the dog to the food, it wasn't an automatic reflex. Something else was actually going on in the dog's head. Now, he didn't know what. Some people were very interested to find out what was actually going on in the dog's head. So one of his pupils devised the following very bizarre experiment. You take a sheep. You place the sheep on a metal plate, just 1 foot. You then attach that to an electrical switch. And when you ring the bell, you electrocute the sheep. And the sheep is very happy about this. Now we have our response scenario marked out here. The shock is an unconditional stimuli. The bell is a neutral stimuli that becomes the conditional stimulus to the unconditional stimulus. The leg raising, which I can tell you the sheep learns bloody quickly, is a conditional response based on those stimulus conditions. It learned to do this when the bell sounded. However, did that become automatic? Did the sheep actually know what was going on? Or was it just mindlessly like the cat being hit by a ball? Was it no thought at all, like the dog running for food or salivating when it heard the bell? Could the sheep rationalize on these stimuli. How to test that? In what I'd like to explain as the 3 o'clock in the morning strokey beard moment, they came up with an answer how to test it. You hand the sheep upside down and put its head on the plate. You then flip the switch and ring the bell. Anybody want to guess what happened to the sheep? Well, actually, there's a little proof here that sheep are smarter than you think. It moved its freaking head. Psychologists, in their constant pursuit, are constantly doing amazing things to animals. And in part 2, it gets funnier. Excellent.
Next up we have Ed Rowley, who's talking about building LCX containers with Jenkins and Ansible. So, all sorted?
Let's see. Okay.
Marvelous.
All right then.
So, here's that.
Probably helps if I move that out of the way. Okay, so I work for iWeb. We are a design agency, but we also do web hosting, our own web hosting. I work on the operations team, and we basically set out the hosting for the developers so that they can deploy WordPress and Magento websites. So how we work is we have we use LXC containers running which are deployed using Ansible, and we've built a very simple little CMS to allow the developers to basically build their own hosting. So this was hastily prepared at lunch this afternoon. So we have an admin. You can go in, you can submit, you can create your hosting. That goes off and submits a job to Jenkins, which starts building your hosting. You can see Jenkins is running an Ansible play. And then this is we use Versha to actually manage the LXC. So we're not using the LXC tools directly. This is the XML for the VM that's created. This is me logging into that VM. This is me creating a simple web page. This is the web page. Our whole thing is run off a simple Flask. The CMS that you saw at the beginning was a simple Flask application, and a machine is defined in the table. This is just using SQL Alchemy. This is the thing that pokes Jenkins, just submits a job to Ansible, again from the CRM, CMS. We use Jenkins Job Builder, which makes it really simple to actually define these Jenkins jobs. And this is the bit of Ansible that actually commissions a virtual machine. What we do is we create an LV, a file system, using create a logical volume, check if there's a file system there, make the file system. If it's not, mount it, and then we run the bootstrap to build a really minimal Linux. We then boot that up. This is that slide, so I'm going to race through it a bit quicker than I thought. And you have your running environment. The one thing that we found is by tying together the CRM and Jenkins and Ansible, basically what we can empower the developers to go off and do a whole bunch of things. So we have Turtles of Fire, which is which is kind of the reverse process. So it takes a running machine, turtles it up, turtles the database, and then it creates those as artifacts on the Jenkins box that a developer can go in, download them, run them on their local machine. There's reverse Turtles of Fire, which takes those same turtles and then shoves them back up onto another virtual machine that we've created through the CRM. And we've also got the same thing working, like deploying out to AWS and things. So all of this is basically so that we don't get asked anymore to build hosting for people, and we can go off to conferences instead. So that's it. So that's it, basically.
So next up we have Aaron Brady. Is that right? He's talking about laptops, our infrastructure, and OS X. So I'm guessing this is a talk about how wonderful Macs are.
Yeah, obviously, going to work. They are
It's wonderful. There are incentives, so if anybody wants to sign up for a lightning talk, who have I missed? There's sweeties from Gerald. So if you want to sign up for a lightning talk, it's not too late. Well, I'll be opening the floor again.
Cool. Right. Hello. I work in the same place Ed does. I work for operations at iWeb, and we manage hundreds of machines. I imagine lots of people here manage a lot of machines. It's just to show the 580 figure in the top right in terms of we wouldn't put new Linux machines or POSIX machines in any way on our network that we wouldn't consider managed in some way. We happen to use Ansible at the moment. We've previously used Puppet. And we use lots of automation in our environment. But the one place where we weren't using automation was actually inside people's desktops, or for people's desktops. We have about 24 employees, just about 20 Macs, and a couple of Windows machines. The Windows machines are a bit of a lost cause for us, but although there are tools out there. But so I just wanted to talk about what we're starting to do with laptop automation. So OSXC is a set of well, first of all, people here familiar at all with Ansible, at least knowing what it is? Yeah, there are some nods, there are some hands, that's great. So Ansible, in recent releases, has a thing called Ansible Galaxy, which is like CPAN for Ansible. So you can import reusable modules. And OSXC is largely 4 modules for Ansible, which handle the heavy lifting of managing the package manager for OS X, or the package manager for OS X that we use. So people who've used Macs, especially Unixy people who come to use Macs, often go with Homebrew. Homebrew lets you install software in a repeatable way, largely for command line software. You get these little, you get basically Ruby scripts which say how to install a piece of software, so it's a repeatable build. It says, much like a port file or anything on a BSD, and there are actual ports of Homebrew back to BSD or back to Linux that you can use. So this is fine for the command line tools. So we're a LAMP shop, so people have PHP and they have Apache on their laptops and they have MySQL. And up until very recently, we've basically handed people a blank laptop and gone, crack on. Just go and build your own dev environment. Everyone builds them a bit differently. Everyone installs whatever the latest PHP was at the time that they got their laptop, so you can date their machines that way. More recently, oops, remember all the right key presses. More recently, we're using Homebrew in combination with Cask, which is an extension for Homebrew, which lets you manage basically GUI apps or anything that would be packaged in a disk image or anything that would be a .app. So you can install your web browser this way. You can install all the other things that make up a Mac, because we would pre-configure a machine with all the Homebrew with Apache and PHP and hand it to a developer and they would go, where's Photoshop? So Cask lets us do that through basically the same interface. Okay, so these are the 4 Ansible Galaxy requirements that OSXC provides. Again, the major important things being that it gives you a way of managing Homebrew and Homebrew Cask. And so just to show what these are the steps that from a brand new, out of the box, once you've hit next 5 or 6 times to go through the install process, we can hand a developer this. They copy their private key, because it's actually on our, shouldn't be showing the URL. Sorry, Neil. It's actually on our private Git install. So they have to clone this down. This is just forked from a beginning repository that they provide. They run exactly these commands. They need to run xcode select to prompt them to install the command line tools. They need to install pip with easy install, so they can use pip to install Ansible. And then they need to get some prerequisites from Ansible and simply run that bottom command there to actually build their desktop. Now, I'll actually just kick that off in the background. I know it's a live demo, and I'm not relying on it to work. Brew unlink can't say, because you get cows if you have cow say installed. Excuse me a second. There we go. So let's give it your sudo password, which is whatever you just logged in at, and it's going to go and do a few things. Update Homebrew, update Cask, and I'll just show you what the actual books are doing now. So this is our actual build. There's 2 steps. There's the install step and the configure step. So 1 minute. Jeez, that was quick. So we go through, these are all the packages, zipcalc, all the command line things. Cask packages are the more grown-up things. We can give them a machine that's fully configured with Firefox, Chrome, a text editor, graphical tools because they don't want to use Git in the command line, regex editors, things like that. We can also do some slightly more complicated things about managing multiple versions of PHP. All of that's custom at the end. That didn't come, but it's just regular Ansible. So anything you can do in Ansible, you can do on their Mac. Here's some of our configuration stuff to do a bit more, even just if it's just copying, giving everyone the same ZSHRC, giving everyone the same Git config. Yeah, those are some examples. That's what Git configs look or SH configs look like. People have been adding their own things, so our developers who are not operations people, because it's just a simple YAML format, can come in and they can make their own. You can't actually see that it's not me, but it was someone else who authored that because they had some more software they wanted to add. We can pre-install the fonts, even that our graphic designers use, and because the graphic designers, they can also install the software that they use, Spotify. And people can have their own builds for people who are a bit picky, which is typically operations people. And these are the packages just for mine. 10. I can hear it coming. Thanks.
8, 7.
That's it.
I'll go back to screen sharing. Thank you very much, Hazel.
You joined two sentences together, and okay. I'll go with VGA then.
Yeah.
Oh, hang on. Hazel's talking about using file system capabilities with rsync, or how I learn to stop worrying and love.
CapDAC research.
Thank you. Yes, I can't read that.
Give me a moment. Where the bloody hell? The screen layout editor. I'm staring into the projector. Give me a moment. Output VGA1. Why do you hate me, AR and R? Fine, XR and R dash. I presume the time spending fucking about the projector doesn't count, right?
No. Well, maybe.
Rotters. 1024 by 638. Match for laptop resolution, so there is a hope in hell that it will actually work. Hey! And right. Hello. I'm starting with a projector. Excellent. I don't have a clicker. That was well. There we go. So yeah, rsync. Lots of you probably use it to back up servers, and some of you will probably have it set to SSH in as root. So you don't want to have a backup daemon or whatever. You don't want to have to use file system dumps or tarbors or whatever. But the problem is that well, you can have keybase SSH to root on these hosts, but then, well, your backup server's got full rootly powers on there, and if someone cracks into the account, you're a little bit stuffed. And so I was trying to set a backup for the hack space, actually, but I was like, well, what if we could just give it the rootly power it needed, which is CapDAC read cert, the ability to read any file in the system, the ability to traverse to any directory. So as it turns out, you can actually use PAM-cap to grant those capabilities on a granular basis to individual users. And then you can use file system capabilities to grant the ability to inherit those capabilities to specified binaries. So I'm just going to skip the what is PAM slide. I assume you all know what PAM is. And the other capabilities exist. CapNet bind service is a common one. CapDAC override is the one that lets you write to everything. There are 3 different sets of capabilities: permitted, inheritable, and effective. And so we take advantage of the fact that we put the, let's see, which one do we put it in? We put it in the effective and inheritable set for user bin rsync, and we put it in the permitted and inheritable set for the backup helper user. So yeah, basically we create a helper user, and we allow that an SSH key to log into that user. It gets the ability to have, it is allowed to use the capability, but it doesn't have it in its effective set. The rsync binary is allowed to inherit that, and is allowed to actually become effective. So then when you run rsync as that user, it can read everything. Now, of course, that's still a big deal. You can read that Shadow, for example, obvious one. But it's better than them having all the other rootly powers like CapNet admin, CapDAC override, CapF owner, etc. And so we obviously add it to the PAM config. We set up a user with disable password SSH key authentication. Because I'm paranoid, I added a special thing to SSH deconfig just to even if someone were to fuck about with the thing and set a password on the account, you still couldn't log in using it. And a cron job on the server you're pulling from that shells into backup helper at, and And yeah, Tim pointed out last time that I could just use -x. And it pulls all the files down. So, but obviously, like I say, there are some caveats there. The main one is that capdac read search does exactly what it says on the tin. It's still one of the rootly powers, and you shouldn't give it out like teeth. So, and of course, if someone were to somehow compromise some, so if someone were to crack into that account, they have a lot of privilege. And also, obviously, the client or backup example.com in this example is still running as root. We could have stuck it in a zone, or we could use fake root, or use containers or something. But in that particular scenario, if someone were to speak bad rsync protocol and try and break into your rsync client somehow by pretending to be the server, again, you could be a little bit stuffed that way. And so, yay, plus side, rsync is no longer running as root on the file server, the machine you're backing up. But yeah, capdac read search is, yeah, it's a big hammer. Yeah, and so yeah, like I say, we could combine it with fake root. We could combine it with ZFS snapshots on the server we're backing up to, but that's just fairly, or the second bit there is fairly ordinary, what you could do with rsync. But yeah, questions? Don?
Or other capabilities to further restrict the access of your capdac read users?
1 minute. That's an interesting question. I haven't thought about it. Next. Anyone else got a question that I can answer in 1 minute? No? Seriously?
Sweeties are given out like sweeties.
Sweeties are given out like, yay. So I hope you didn't think it was flipping awful.
Marvellous. Who's next?
You.
Oh, no.
Oh, I have to out now.
Easy. The best laid plans. Right. At least I know what I'm doing. So, in my copious free time, I prepared extensive slide set, as you will see. This took a lot of preparation.
And the blue really brings out your eyes.
I thought so, yeah. Given the brown. So. But I wanted to talk briefly about ShadowNMS, which is a solution that we at ShadowCat have been working on based on the wonderful OpenNMS product. Our OpenNMS is wonderful if you're a systems administrator or a network administrator. It's a fantastically technically capable piece of kit. However, it's not what you want to present to your users because it gives you lots of information, lots of really shiny information, and it's just massively information overload. So what we've done is we've produced something that is based on that does some nice API calls and REST stuff and magic behind the scenes to present a simplified traffic light system for use by non-technical users. So it's a slight plug, which is okay. So that's what I wanted to talk about. So if you're interested in possibly trialing that and giving us a hand maybe to do a little bit of development as applicable to your particular situation, then we'd love to talk to you. Grab myself or Mark or Tom, if you two like to stand up so people can know who you are. These two people. And we'll give you a free account in which you can have a play and tell us what you think. So
Would you like to see it? It should come up on screen.
oh.
Keep on talking.
Looks amazing.
It's amazing. Look at that. It's just like Doctor Who. How amazing is that if we could do that? Can you embiggen it? You've embiggened it.
I've embiggened it for you.
You embiggened it a bit too much.
There you go.
So there we go. And we have this nice red, amber, green.
Pretty dark.
And you know, we can click on the devices and see information, and
What do you want to see?
it's all very shiny. And you pretty graphs and stuff like
Look
that.
at ISVP.
So that is it in a nutshell. If you are interested in trialing that and helping us actually do some software
Should we
development,
see how easy it is to have a new device?
go on.
Device name 90, it does all the work for you.
And then
once you're inside,
it uses
you
the
can turn on or off the things it can see, and even add websites.
so it's using the functionality within OpenNMS to do service discovery and all sorts of neat things to then present the user with a minimal set of information that they can then tweak without having to have the detailed knowledge.
It's only viewing things that are visible to the world, so it does not need to be installed in your system.
So there you
It
go.
needs to be installed in your user system, doesn't affect any of your security or your networks in any way.
But yes, talk to us. Fantastic.
Get a free
Free trial. Thank you. Sweet tweet. Why get sweeties? Thank you.
Just there we are. Thank you. Oh. Really? F. Oh wow! Oh, that's clever. Right. You start the clock then.
Go for it.
Right. So, what the hell am I talking about? Hands up if you use Bash. Yeah, right. Great. Hands up if you use it every day. Great. So.
About Sundays.
Especially Sundays. You're already using tab completion and the arrow keys. That's a given. You've probably already got a shiny prompt. I am not going to talk about that. I'm also not going to talk about the job control, redirection, and all the other magic you know intimately to do your work. What I'm going to talk about is the guff that's in the man page. Sorry about that. Bear with. So, this stuff is in the man page, but people read it without really knowing why it's useful. When I say MX, I mean press Alt-X, etc., etc. Little known feature, if Alt something doesn't work because your window manager gets in the way or whatever, you can press Escape and then press the key, and it usually gets through. So, we all navigate on a line in Bash using left arrow and right arrow. If that doesn't work because you're SSH'd into an evil Solaris box or something, try Control. Not arrow keys, sorry, home and end. Home and end often don't work. Control A and Control E will take you to the start and the end of a line respectively. And if you normally use Control left and right to move along words on a line, then Alt B and Alt F for back and forwards will probably work. What else have we got? So obviously Enter makes your command go. If you've got a nice long command and you say you want to save it to a file or you want to edit some bit that's just in the middle somewhere, Control X, Control E will open it in $editor and you can hack away, and then when you save and quit, it'll run it for you. Control O does operate and get next, so you've got a long history, go up a few times, and then press Control O, it'll run that command, and then load the next command in your history. Press Control O again, and it'll do the same thing. Little undocumented feature that's not in the man page. If you do this and you happen to be at the end of your history, it'll get to the end and then go back to wherever you started. So this is really handy for edit a file, make, run it. Edit a file, make, run it. Repeat ad nauseum. Okay, this one might be my favorite. You've just run a command. Let's say it's mcdir, some really long name that I really don't want to have to type again. CD alt dot. Exactly, alt underscore, it's exactly the same. You can keep pressing this and it will keep going back in your history and fetching the last argument for the commands going back until the beginning of time. Alt and a number, and then alt dot or alt underscore will fetch the numbered argument from the previous command, not the command itself. That if you want the command name, sorry. What else? Alt hash makes a little comment on the line, so it will put a hash at the start and then give you a blank line. It'll put it in your history, so if you're later looking back through your history and you've got some command that you never executed, but maybe it's a little explanation of what you meant or something. Tab, I'm pretty sure people's tab keys are getting pretty worn out on their keyboards. Maybe you didn't know that Control X asterisk will take everything that tab would have done and just put it out in words on the command line. Alt left brace will do the same thing, but it will put it in curly brackets. I don't know why that would be useful. Anyone? For loops, yeah. Well, for will iterate over a list of words as well, but if you want to hack it about, then fair enough. Control Alt E will expand out aliases, variables, globs, and just stuff them in for you so you can see what you're actually about to run. And
1 minute.
Hey, this is going quite well. I reckon I can just stand here for a few seconds. Nailed it. Alt backspace will kill a word, so we'll Control W. Don't get confused in Firefox, because Control W will close your tab and then all bad things. Alt D will grab the word in front of the cursor, if that's useful, and Control Y will paste whatever word back onto the line. Control R searches backwards. Control R, start typing. It finds some commands for you. Control V, and then any character inserts that literally or verbatim. And Control D, as you all know, means end of file, sod off.
Thank you very much. Lastly, we have Matt Trout, who's talking about stupid systems tricks.
Also, you can tell when it's good on Solaris, you know, go back STTY array and then the backspace key. The second.
And Control L. Control L.
Or if escape isn't working, talk about how get to
I would also note that if you're an ancient Unix box, K-Shell will handle most of those, and that if you use a real text editor rather than this strange list-based graphical operating system, set -OPI will get you real key bindings.
By the way, can I just mention something about that? Turns out that if you do Alt-0 and then doc, you can get the command name from the
Sweet.
so it's not just 1, 2, 3, 0 or so.
Oh.
Is anybody disturbed by how many of those they knew?
So, stupid systems tricks, because along with whipping minions to wrap shiny things around monitoring stuff, most of what Shadowcat does is outsourced insanity for Perl and systems automation. However, first I'm going to start off with a couple of tales from the past. Back in my ISP days, you'll be able to tell this by the fact that we were dealing with Apache 1.3 on Solaris. 30,000 virtual hosts, we were moving onto this platform. So generated all of the configurations, started Apache. Apache allocates 3 gigabytes of swap, and Solaris wedges hard and doesn't respond to a key press for an hour. I did eventually manage to get it back. It then served 3 requests and wedged again until I had to hard reboot it. This was obviously not optimal, especially since back in the ISP days, our systems team were geniuses. As a result of which they reported this to me 2 days before go live. So I crack open the Apache sources, go and dig in. Virtual host directive in Apache 1.23 copied the server config struct and then poked the virtual host settings in. That was how it did defaulting. So you are copying the entire server configuration per virtual host. With 30,000 sites, that's not good for memory consumption. We needed a different plan. So I went, well, okay, we're using an LDAP backend for authentication of everything. Let's look at modv host LDAP. Modv host LDAP won't do su exec. One of the whole points of this migration was we wanted su exec. We were sick of people running CGI scripts as the web server user. So you can do that with a virtual host. How else can you do it with mod userdir? Mod userdir, that means it needs to be a home directory. So you add domain.com as an alias to the LDAP tree for the primary FTP user, and then you apply mod rewrite, because mod rewrite's always a great idea. Rewrite foo.com to foo.com/foo.com. Now it's serving the files. You also do the rewrite for the CGI scripts, at which point mod userdir kicks in and runs things as the right user and group. And it actually worked really well. And then I spent several weeks fighting the fact that lots of people kept uploading broken copies of formmail.pl. I have never been so embarrassed to write Perl in my life. Anyway, we also had a fun one where we had spam problems. So 7 QMail servers, this was 2001. Hence we were using QMail, because whatever. Can't clean the queue while the node's running. So what do? We have NFS mounted mailboxes. So I created a directory in there with a flag file in it. There's a cron job that looks for a flag file of that mail node's host name. What it does is it starts up, telnets into the load balancer, takes itself out of the rotation, shuts down QMail, cleans the queue, starts QMail, puts it back into the rotation, and then redrops the flag file. This was a little bit ghetto, but it did achieve good by Spam Blast. Okay, now, how about some things that actually weren't incredibly ill-advised and just look like it? MySQL DDL testing. Of course, MySQL doesn't do transactional DDL, so you can't test it in any sensible way except having a throwaway instance that you have to rebuild afterwards. Let's assume you don't have file system snapshots. So what you do is you spin up a system, you rsync the data directory from one of your slaves, that's fine. Now you do it again, and then you do it again, because by the third time it's only going to take a couple of seconds, so you're not actually that far behind. And at that point you just say fuck it and start MySQL, because InnoDB recovery will take care of it. Wouldn't necessarily do this for a production box. I have done it to bring up a slave in very short order, because we'd run out of slaves and having a slave at all was more important than whether it came up perfectly the first time. And yeah, screw my ISAM for that trick, I don't even care. At which point you run the DDL, you watch it break, you shout at the developers and you repeat. The rsync goes a lot faster the second time because the way InnoDB does writes. The worst one, though, was Postgres. We were doing streaming Twitter firehose analysis into Postgres on EC2, so the I.O. was shit. So what we needed to do was staging data and put it on tempfs. So you insert into the table, aggregate via cron, fine, but after reboot, Postgres refuses to start because there are errors on the transaction log entries for the tempfs stuff that doesn't exist anymore. Didn't exist yet. But it applied the other transaction log entries fine. I actually went through the sources to double check. So what you do is you start it, you parse the errors, double check the errors are only on tempfs, and then you reset the transaction logs. At which point you run start again and it starts fine. Postgres does now have unlogged tables. That would have been a much better idea if they'd existed yet, but it worked. Sufficiently advanced insanity is indistinguishable from technology. Thank you very much.
We've still got an hour before we need to start walking to the hall.
There's one other question I suppose we should ask is,
You want sweeties?
can we tempt anybody? There's time left? No? None of the York TV guys want to talk about what they're doing? No, they're looking very shy. You did a grand job, lads, thank you.
Okay, well, thank you very, very much for coming today. I hope you've enjoyed it as much as I have. Which incredibly, I seem to have enjoyed it today. It's good. Organising isn't always fun. Iterate again, we are having dinner in the Merchant Adventurers Hall. We will be meeting at 6:15 in the hotel lobby to walk over there at 6:30. Dinner will be served at 7. There is a bar, so bring cash. And then we'll be going to the pub afterwards. Thank you very much.